Thank you, Peter. And thank you for welcoming to this wonderful occasion and seeing so many people here tonight. Can I just sort of share very briefly my very brief career, because it kind of highlights an important lesson for me, and hopefully will be a guidance for those who are here and looking for their future career. So my father's an Air Commodore in the Royal Air Force. My uncle's a Brigadier General. My son has just graduated in geopolitics, international relations, about to join the Royal Marines. He wants to follow in my father's footsteps. When I wanted to be a meteorologist. I've always wanted to be a meteorologist, a weatherman. And when I expressed my desire to my father, he said, "Don't be so silly. We fly through clouds. We ignore your advice." And there was a bit of echo of that this afternoon, I noticed. And so I joined the bank. I'm a trade accountant. I was a bank manager. And I remember the time when I was looking outside the window, talking to the regional manager. He said, "What are you looking at?" I said, "In about 5 minutes, there'll be a thunderstorm." He said, "Paul, can you just leave the building and join the Met Office? You've always had the passion to be a weatherman, a meteorologist. Go and do that. You've wasted 5 years of your life doing something you don't enjoy." So my advice for everybody in this room who's embarking their career, follow your passion. Don't get swayed by people saying, "Oh, you should be doing that," because you do what's right for you and do what motivates you, because that will get you to a position where I have fortunately become the Chief Meteorologist at the Met Office. So that's my story. And the story I want to give in terms of the Met Office is, so it started in 1854. Vice Admiral Fitzroy. Vice Admiral Fitzroy is the captain of the Beagle, HMS Beagle, who was part of the captain for the Charles Darwin. Now, there was a big disaster which happened in 1856, 57, a big storm which wiped out a lot of the Navy at the time. And he was devastated by the impact it had on the Navy. And from that point, he said, how can I make the difference? How can I make sure that doesn't happen again? And what he did was, he used his innovative thinking. He looked at what was available at the time, and that was the telegraph. The telegraph was the big advanced technology that was available to Fitzroy. And he also used his ingenuity by looking at observations, reading what the captains of other voyages have come back with, and understanding the role and the atmosphere, the revolution of the atmosphere. And what he did was he put those things together to develop what was then a radical new service, and that was the gale warnings. That's the shipping forecast. And that really is just a good example of how someone like Fitzroy, way back in that period in the 1800s, developed something which was really novel and technically brilliant in order to solve a problem which was currently happening at this day. And then we go back to 1944. Group Captain Stagg. Group Captain Stagg. To be honest with you, the technology now, we can fly people to the moon, but we can't get the technology working sometimes in the building. So hopefully now we'll be able to get things moving. Oh, here we go. We just raced through the whole presentation. Here we go. So there's Fitzroy, right? Vice Admiral Fitzroy. And as I said, he was novel by using telegraph and how he moved it into new technologies and to develop a new service. But Group Captain Stagg, a remarkable piece of decision-making, because you may be or not aware that D-Day was cancelled a day before the launch day, right? And that was because of weather. Because it was predicting at the time a depression which was sufficiently strong, which rendered the safety of the crossings at that time. And he took a brave decision, probably one of the best meteorological decision-making I've ever encountered, of saying we should not go. It was the following day when there was a very temporary ridge that came across, was sufficiently, that window was very tight, to be honest with you, was sufficiently light that enabled the crossing to take place. And if you go to the Op Centre in Exeter, we have this genuine map, this graphic here, this chart of Group Captain Stagg and his analysis at the time. And when you look at the detail of the observations, they were done by those who had taken their lives at risk from the resistance. So they were reporting the weather at the time, and without that information, we would not be able to provide the advice to Eisenhower to go or not go. And Eisenhower, when asked after D-Day, why were we so successful? He said we had better meteorologists. So I thought that was a good case for my father to say, actually, meteorologists are important. And then we went into impacts and partnerships. So we had a terrible flood in 2007, summer 2007. And I was asked by then the chief executive to work with Sir Michael Pitt to see what we could do to prevent something like this happening again. And out of one of the recommendations was the establishment of the Flood Forecasting Centre. It was a partnership between the Environment Agency and the Met Office. And I've developed a very first profession called hydrometeorology, hydrometeorologists. I believe there are other professions out there we haven't even thought about. I think there's people in this room who, in future, can develop new professions, new ways of thinking, new ways of career and skill upskill that we did at the time in 2007 for the Flood Forecasting Centre. And then he said, you've done a great job in flooding, but can you do all hazards now? Space weather, volcanoes, earthquakes. Everything all that has related to meteorologists providing the guide and the frame for these hazards was set up through the Natural Hazards Partnership, which I created with the Cabinet Office, and with which we established the very first guidelines document for the United Nations of how we then move from weather forecasts, just saying what the weather's going to be, to what the weather will do. We move into impacts. And when you move into impact, you're in a whole different paradigm, because no agency can do it on its own. You have to work with partners. You have to work with communities, in order to understand what is the impact of weather and climate on communities and society. This is the start of the journey. We've still got a long way to go. And the need globally at the moment, and I can assure you there is a need from the world for this advancement of thinking, is more important now than it's ever been. Advances in meteorology. It's been known as the Quiet Revolution. In my space of 30 years as a meteorologist, I am staggered at the advancements of technology and science. For every decade now, we can pretty much gain a day's accuracy. But it's more than that. Because of this capability that we have to our hands, and it's, and the government agrees with this because they've just invested 1.1 billion working with Microsoft to develop new capabilities in technology, supercomputing, to unlock the science of climate and meteorology. That wouldn't have happened if we hadn't demonstrated the value that we can provide right now. And be reassured that that technology and that capability is a crown jewel. And you have an opportunity here, those who start in their career, to really embrace it and make the best of that new tool that we have, because it's massively wonderful, and I'll show why in a minute. So why is it so special? Well, one of the things that we need is observations in order to create a forecast. So we have observations from satellite, and I'll show you in a minute what the observations look like globally. And when we feed those observations into a simulation, we're able then to predict the forecast. And from that, we can use next generation supercomputers. We can start using other partners' information, sharing that information to unlock the impact which I described earlier. Can I just show you what it looks like? So I'm going to show you a simulation here. This simulation is the information, the observations which are ingested into the models. It's taken at one particular time, and you'll notice there, the keys there, you've got yellows showing conventional observations and green. The yellow one, keep an eye on, because that's from airplanes. So when you take a flight, it records the wind, temperature, humidity, commercial airlines, and they share that information. So when I show this animation, you'll see the flights. All that information is being taken into the models and data simulated, because without that, we cannot predict the weather. We also look at surface observations. You'll see the green all speckled across. But you also notice where there was very little observations. Africa, the Pacific. And also, more importantly, you see the swathes of satellite information going across. So if I run that sequence now, you'll see the power of millions and millions of observations, which we ingest every single minute of the day. So you can see the yellows there in the United States. Those are airplanes. You can see the satellite swathes going across the seas, across the continent. You can see the greens now breaking up across Europe there. Look what's happening across Asia now and Australia. Flights are now taking off. And what's happening across Japan and Southeast Asia. This information is continuously being digested and fed in to the models. And one thing I have to say, which is really important, especially given what's happening now, if we don't have access, we don't share information and data, everybody's forecast deteriorates. Everybody's. So in other words, we have, since when I was part of the WMO, United Nations, I think one of our biggest successes back in 1954 is we signed a contract with 192 nations that will share observations at no cost. It's free. Because it was a recognition that we need observations from Brazil in order to get our forecast right 5 days' time in the UK. And Brazil needed observations from the UK in order to get its forecast right in 10 days' time. Without that sharing, we don't have a forecast. And Laurent said the flap of the seagulls in Brazil could make an impact on a hurricane in the United States. That is true. So there is uncertainty, there's the subtleties, the detail of the information is so critical when we really need it most of all. And that's when we're dealing with extremes and climate change. So this is the sort of the endeavor that I would be embracing and continue to embrace, is that the sharing of information and data, observations in particular, and also model data for those who don't have access to that data, is one of the most biggest tools, the most gift we have for people to stay safe and thrive. So we will go and take it forward to the next bit in terms of how do we take all that observations and then how do we then ingest it into a forecast. So I've shown you the observations on the globe there, and we're able then to data simulate that, simulate what's happening now, which, to be honest with you, takes most of the computational effort, right? It's very time-consuming and energy-consuming to actually generate the analysis. Then we run the forecast. We run the forecast for the globe, because as I said, we need to know what's happening in Brazil to get it right for the UK. And we run it from now, we run it through 5 days, a week, seasonal, decadal, climate. It's a seamless prediction system. We are the only country that is able to have a completely unified weather climate system. We are really good in the UK. We should be proud of this. And we should be able to build on that brilliant expertise that we have, because we have it to our fingertips. And then we can take all that information and really get into the nuts and bolts of really what's happening at the local detail. Because the finer the resolution, the finer the detail, the more accurate we are. And then we were able to run it and translate it into impacts and risks. And that leap from weather, local meteorology, impacts and risks is a huge gap, right? We still got to fill that. Because in order to have that environment where we can share that data and that knowledge, generally requires transdisciplinary working. Because without that, how can we translate that? We need to bring the poets. We need to bring the painters in. We need to bring people in to work this through. That's why I'm working very closely, because I'm a fellow of the Royal Met Society. And I'm also with David, with the fellowship scheme in the Royal Engineers Academy. I'd like to bring the British Academy so that we can build a transdisciplinary academy to unlock this huge potential that the UK have access to. And look at this. This is a forecast. This is not observations. This is a 5-day forecast from our high-resolution models, which we're running now. It's a remarkable achievement. And this is what's available just about a week or 10 days ago, right? Because we've just upgraded our models. Madagascar there's a cyclone which is about to hit Madagascar. Madagascar is one of the United Nations warnings for all countries, which identified of huge vulnerability to future climate shocks. Now, if you look what's available now, look at the detail. Past, now. You can see the structure in the cyclone. You can see the detail in the topography. You can see the detailed response in the oceans. This is fantastic. If you want to embrace new technology and evolution and the new science and satellites and oceans and how do we translate that to save life, then this is the career you want to go down. The other thing I want to talk about as well is global scales, interactions, and extremes. Because what's clearly evident from my work with Newcastle University and the Hadley Centre is that we get this period of time in the planet when things go mad, things go crazy. It's called blocking patterns. We've seen a few of those in the last few years. September 2023. Look at the Valencia floods in Spain, Libya floods. They were all locked in a global pattern where not just Valencia was suffering, but other parts of the planet were suffering. And why? Well, because the atmosphere gets itself in a frenzy, but also it's largely driven by the oceans. Now, if you were coming on a journey from Mars to the Earth, and you hit it on the right position, this is Earth. We tend to look at Earth as the standard maps, you see the land. But actually, if you're coming in from one particular direction, all you see is water. And when I saw this picture, it really struck me. Because it shows you that, in this occasion, that a lot of this part of the planet is ocean, water. And we don't know much about oceans. Oceans is if anybody there who really like to understand oceanography and the role of oceans and how it plays in the atmosphere and climate change, please, we need you. Because it's a science which is just starting to develop, because we don't understand it at the moment, largely because we don't have enough observations. The buoys and the drifters, they're very few and far between. Satellite are able, but the satellite can't really penetrate down into the oceans, right? So we just need some new innovative ideas about what's going on in the oceans, because I'm convinced of it. That is a big driver for climate change. Can I just show your hands? I'm just curious, if you don't mind. How many in this room, can you just show your hand, think the climate's changing? That's pretty everybody. How many people think it's due to large proportion anthropogenic, human influence, Yeah. And how many in this room are fearful, are scared of the future for climate change? So about 50-50. And how many people think it's an opportunity? Yeah. So I think that's true, because what the social sciences are saying, that we can tend to unavoidably play on the fear factor without linking on opportunities too. There's a trade. There's an opportunity there, taking the most you can from the atmosphere. So that's why the Met Office mission is to stay safe and thrive. There's a thrive element as well. But look, we don't want anthropogenic climate change, right? We need to find ways of being able to adapt to it. And that's another thing I want you to take away if you could. We tend to, in the past, been looking at mitigation, looking at the mean. Those days are going quickly. It's going to happen. We're going to see some big extremes. It's about adaptation. We need to go to resilience and adaptation pretty quick. Because mitigation, I think, at the moment in time, hides the variance which drives extremes. And it's the extremes which are causing a lot of the damage. My work in the World Bank and the insurance and insurance companies are demonstrating that the extremes, and hydrometeorological extremes is right up there, is becoming more prevalent and more damaging than ever before. And just an example of what I was talking about, these blocking patterns. This is 2021. I don't know if anybody remember the Germany floods and the flash floods in London. Well, look what happened at the same time. We had the droughts across the United States. We had the drought conditions happening across Southeast Asia. We had the huge floods that happened across China. We had the Arctic in a blaze. And it was also on the back of when we had that huge heat wave in Canada with the wildfires. It all happened at the same time. It gets blocked. It gets locked in for 10 days. This is a difficult situation for insurance companies, for the world trade, for field security, energy security. Because you can manage one hazard and one disaster, but what do you do when they're all happening at the same time? It's compounded. So we need to find ways of being able to understand why are we getting these type of events, and I think we know, but more importantly, what does it hold for the future? Are we going to see more of these? Are they going to be in the same place? Because look at that, that's hitting the breadbaskets of the planet, right? United States, Ukraine, Western Russia. These are the places that are, the food baskets for the planet. So is that something we need to be concerned about? So for those who start in their career, and you want to make a big impact on the planet, to understand what the consequences of these blocking patterns and other things around climate change has on society, on trade, on business, on commerce, then it's a time to come and join the club, because we need you. And it goes on to my next thing, complex cascading interacting risks. It's systems thinking. So I've done a lot of work with Network Rail and National Grid. I wrote a report with Dame Julia Slingo, following the Stonehaven disaster, which happened in August 2020. And unfortunately, we lost some lives. And the chief executive said, we really need to work out what happened there. And in our report, which you can Google it and find it on the public website, we concluded it's really important to have academies. It's important that we bring the industry and the science and other facets of private to unlock the power of the impact of future climate and meteorology. And one of the things also came out of that analysis that we did was that events seem to come in buses, right? If you have one windstorm, often it's followed by another one, and then another one. This is a case in point. I don't know if you remember Dudley, Eunice, and Franklin. Forgive me, I'm a meteorologist, and I do kind of remember these events. But Eunice was the one that caused, from a meteorological perspective, the most interest. We call it stinjets, these poisonous winds that the Norwegians called, that on the back end of a low that came in and caused huge amount of damage across infrastructure. And Franklin, from a meteorological perspective, wasn't particularly interested meteorologically, but it caused the biggest impact. The reason being is because you're building up vulnerability and exposure, right? Each storm that came in prior to Franklin wetted the catchments, primed for the strong winds that came in with Franklin to enable those trees, which were fairly well rooted, unable to get stable. So when Franklin came in, the impact was much, much larger than we anticipated, and especially for the rail industry. So that's the other thing, right? It's not about the weather forecast, it's about the impact. The other motivation as well, and there's evidence to suggest this, that if you look at the impact in terms of cost loss and society impact, having compounded, cascaded events results in so much more damage than an individual event in itself. So the classic one is, someone mentioned about earthquakes this afternoon. I'm looking at India at the moment, North India. There was an earthquake in January this year. That means that the structure in India, North India, is pretty vulnerable now for anything that comes along in this early monsoon season. And there's going to be some heavy rains coming through and some snow melt. That means the cascading compound hazard element to it means that if you just took that flood event in its isolation, didn't even consider the earthquake, you would get a different answer, right? Or wrong answer. You're not looking after the people you're trying to protect if you don't take account of the preconditioning and cascading impacts of multiple hazards. Another thing as well, this is my last one on the cascading, is Bernard Brown, the chair of the Climate Change Committee, made the point that even if we get the hazards right, what about the systems? What about if the electricity, the power station gets damaged by a flood? Then that power now is lost for the rail industry, signals. So those people who go and try and fix the power station can't get there. So you have this compounded cascading system impact across multiple partners, across multiple stakeholders of critical national infrastructure. And again, we are just about to unlearn this. We don't really understand this at this moment in time. It's new science, new technology, new thinking. We need people in this room to help us to fix this for us, please, because it's difficult, but it's something we've got to get our hands on. So if that's something of interest about the system thinking and how we translate that through transdisciplinary thinking, then this could be something you may want to wish to consider. This is my favorite bit, my next bit, and it's my last bit. It's social sciences. So I'm a scientist. I learnt my trade in banking, accountancy, numbers. I learnt my trade to theoretical physics, and then applied it through differential equations to the models. And it dawned on me, and I was frustrated as a meteorologist, why don't people listen to me? I put these warnings out, and everyone ignores me. Why do they ignore me? What am I doing wrong? Because I wasn't talking. I was one-way traffic. I was shouting from the rooftops and saying, listen to me, I know what I'm doing. People said, well, you don't know what you're doing. How do you engage critical information? I'm talking about climate change here. We need to find a way of solving the disinformation. For those people in the room, please can you do me a favor? When you look at social media, and you look at other information, and you see something that doesn't feel right, have the courage to challenge it. Have the courage to go and find out, is it right? Don't get swayed by confirmation bias, what other people are thinking. Have the curiosity and the motivation to challenge and to check. Because at this moment in time, we're at risk. And I need you to do that, especially now with climate change. Please, look at evidence-based. Evidence-based, not emotional and speculative. Must be evidence-based. And social behavior science is some element to that. July 2017, I was in the operations center, and I had a call. Have you not looked at the news? No, I haven't. Look at the news. Kovrak. We had no warnings. Look at this. If that was 50 miles further inland, it would have been a parliamentary inquiry. But the storm that created it was just slightly offshore. Close call. Even though it looks pretty damn, right? But it could have been a lot worse. What it exposed is the fact that these events, these terrible, impactful, extreme events, and someone mentioned convection this afternoon, is very, very tight and very, very angry. You know, you get these storms that are so energetic that you get this deluge of rain. I think people call it cloudburst or wall of water events that come out from nowhere. And it goes. And we see many occasions, have we not, recently, of these type of events, these kind of cloudburst events. And my specialism at the moment is trying to understand why we get these sub-hourly rainfall extremes. And I'm unpacking things we've never seen before. So again, if people think meteorology is a done deal, we understand what's going on, we do not. What climate change is doing is exposing the things in the atmosphere we have never seen before, and including the oceans. We are in uncharted territory, a bit, I feel like a Vice Admiral Fitzroy in the Beagle. But we are in that period of change, right? We're starting to unpack things we've never really seen before. And this is one aspect of it I think we're starting to unravel. But this one here, this picture, Boscastle. Had we had a perfect warning, there'd be dead bodies in those cars. There were no dead bodies. Everyone was safe. The reason being, if you gave a perfect warning, people up in the hills got the warning, what would the first thing they would do? They run back to their cars, get out. Because we had no warning, they were safe. They were blind to what's happening. My message is, you can have the best forecast and the most beautiful warnings you ever have, but actually you might do more damage. So another thing, the United States tornado warnings. The warning lead time is 18 to 20 minutes, and they're proud of it. A private company came and said, we do better than that. We can push it 2-3 days. You know, we can push these warnings out. Yeah, we've got the capabilities. The civil protection says, don't be so stupid. We chose those numbers, those 18, 20 minutes are really important because it's the ideal time for people to take shelter. We have shown, that social sciences have shown, if we push out the warnings and you've got 2 hours lead time, people do stupid things. I've got time to pick up the kids from school. I'll just go down the shop and grab some tea and coffee before the tornado arrives. My point is, we have to understand the consequences and the impact of our science and technology in order to make effective decisions to save people. It's not about the best science and the best technology, it's about the best decisions. And this is one case, and many cases to boot. So I think social sciences is going to be quite frank, on par with machine learning and artificial intelligence. I think they're very complementary. So anybody in this room who loves social sciences, we need you. Is anybody in this room who loves machine learning and artificial intelligence and understand how to unpack the secrets using pattern recognition data? We really need you. This is the future, because you can save lives. I think this is nearly, I've got 2 more slides left, and I think I'm going to hit the time here. Early warnings, early action. So New York City. So I was involved in the discussion about what happened in New York City when they had these huge floods. And do you know what? The forecast was brilliant. The warnings are out. But look at the headlines, no warning. No warning because people were caught surprised. People didn't understand what those warnings meant. And what was more important, if we weren't targeting the right people. The people who died were people who couldn't save themselves. The disabled, the people living in basements who can't read and write. These are the people who suffered. Those people who we, generally warn for can take action. They can get off and drive away, right? But it's the vulnerable of the society that we need to focus our effort on. And also because of these extremes, and they're pretty short notice, and I've just showed you the Kovrak event, we just need a different way of communicating to inform people. Valencia, you saw those pictures. There was a red rain warning out from the Met Service. Plenty of time. Why did people get caught? The reason being, because those people who got caught out in their traffic, because they, what they do, they get the cars out of the garage and drive away, right? And they got caught up in the flash floods. But it wasn't raining. They looked out the window, it wasn't raining. Oh, they got it wrong again. The problem was the heavy rain was falling upwind, and it was almost like tsunami wave that came down. And you saw pictures of it, which caused the devastation. So in other words, if we're going to provide a better warning, we need to go back into compound, the other bit, cascading impacts. We need to picture, visualize what could happen. I've spoken to a very important person in the United States after Helene, the hurricane that hit the United States last year, southern United States. And she's an eminent professor, and she lives in the community. And she said, out of all the people who should know better what to do, is me. But I didn't. I couldn't visualize what was going to happen. I got all the science in my mind, I can see the numbers, but I can't picture it. I can't visualize the impact. I think that's the other route for the future, is finding means of simulating events, climate and weather, and using satellite information, almost like a movie, just to describe visually what the impact could be, because words don't land. Numbers don't often land. That might be a different route. So if there's anybody in this room who loves that sort of way of expressing yourself, it's the painters and drawers, right? Then that is the future. We're wrapped in with social sciences. My last slide, and it's the important one for me, is cognitive biases. You probably recognize some in here: confirmation biases, spark effect. There's so many of them, but these are the ones I like, because I see it every single day. I see it for those who are issuing warnings. I see it for those people receipt of warnings and what to do. I see it in science. I see huge amounts in research, confirmation bias. We just need to means a way of unpacking this. I noticed people taking photographs. It is my favorite slide as well. So I would, for those in this room who starting their journey in a career, can you please be conscious of your natural tendencies for cognitive biases? Because you may find yourself on a journey that's maybe not right. You need to diversify. You need to find people you may not get on with, but these are the people you want to engage with, because they will correct you. Say, hey, hang on a minute, have you seen this? So when you start your journey, just be aware that you may fall in that trap in terms of being with people that you like, who are more like you, but actually you may find
you'll benefit by being more diverse and by bringing others who kind of challenges these natural cognitive biases that we all have, right? So that would be another plea for you, for those who start in the career journey, is to consider those aspects of future. So that's it, really. I just wanted to give you a flavour of the power of what we have in our fingertips, the crown jewels of our supercomputers and technology for climate and weather. I hopefully got a sense of the journey that I have taken and the journey that others have taken in this field. And also, I think that for those people who start in their career and the challenges and opportunities that we have in a warming climate, embrace them. We need you as much, and we need you now. So if there's something in that I talked about and you kind of resonate with, welcome your questions, welcome your discussions, welcome your thoughts about what you think needs to be done and how we work as a community to take it forward for the benefit of society and people. So thank you very much for listening, and thank you.